Hello everybody, today I'm going to go over the genetic algorithm. So let me take you first to a brief introduction about what is the genetic algorithm. As you can see here, the genetic algorithm is a method for solving both constrained and unconstrained optimization problems that is based on natural selection, the process that drives biological evolution. The genetic algorithm repeatedly modifies a population of individual solutions. At each step, the genetic algorithm selects individuals from the current population to be parents and uses them to produce the children for the next generation. Over successive generations, the populations evolves towards an optimal solution. You can apply the genetic algorithm to solve a variety of optimization problems that are not well suited for standard optimization algorithms, including problems in which the objective function is discontinuous, non-differentiable, or stochastics, or highly nonlinear. The genetic algorithm can address problems of mixed integer programming where some components are restricted to be integer value. Okay, now this is a flowchart outline, the main algorithm steps. So, the first step is to create initial population, then score and scale the population, then retain a lead, and then select parents, and in the last step we have produce crossover and mutation children. Then we go back again and we score and scale population, then retain a lead, and we can go back again and score and scale population, and so on and so forth. So the genetic algorithm uses three main types of rules at each step to create the next generation from the current population. The first main type of rule is the selection rules. That means to select the individuals called parents that contribute to population at the next generation. The selection is generally stochastic and can depend on individual scores. The second main type of rule is crossover rules. That means to combine two parents to form children for the next generation. The last rule, or the third and last rule, is the mutation rules, and that means apply random changes to individual parents to form children. Now let's solve this problem here. So this problem here is asking to implement a genetic algorithm to solve the following problem. Here we have a matrix of random numbers, and then we have the cost is the difference of the absolute value of each number. Okay, and to solve that problem, this is the program I have wrote. So the first thing here, I have imported the libraries, the java.util and the java.io. And then I have created a class named main2. Inside this class, I have defined a method called absolute value, EBS. It's taking an integer value. This class is integer as well, type integer, and it's static. It takes in an integer a, and then it checks if a is positive, it returns a, and if it is negative, it returns it multiplied by -1, means we always want the positive value or the absolute value of an integer. Then here, this is my main method. Inside my main method, I have declared two integers n and m that represents the number of rows and the number of columns of our matrix. Here I have initialized n to be the integer dot parse int. That's converting any string to a number. The same thing I did for m. Here I have initialized. I have initialized a matrix, integer matrix. Here I have throw an exception try, and inside of it I have created a new file named input.txt. This is where all my random numbers will go, and then here I have declared the scanner method, and then the scanner class, and then inside of it I have two for loops. The outer for loops is traversing the number of rows, and the inner for loop is traversing the number of columns. And I have populated the matrix with all the numbers that the user is going to enter. So by doing matrix ig equal reader.nextInt, this is putting all the numbers inside the matrix, and here I'm catching the exception, and inside of it of course I print the exception. I have initialized the calls to 0, and then again I have traversed the number of rows, the number of columns using the for loop, and I have calculated the cost, which is equal to the initial cost, that's 0, plus the absolute value of the second number of the matrix minus the first number. So it's like the neighbor. So each number and each number has a neighbor. So I take them both and I make a subtraction, and I take the absolute value of that. I add it to the cost, and that way I have the cost here. I'm going to print the cost using system.out.println. The cost is cost. Okay. So that's it for today. Thank you for watching.